questions 11 through 20 on the 2013 Grade 11 Fermat Math Contest. On Monday, Ramya read 1/5 of a 300-page novel. On Tuesday, she read 4/5 of the remaining pages. How many pages did she read in total on Monday and Tuesday? Monday, 1/5 of 300, and that is 60 pages. Tuesday, 4/15 of the remaining pages. So since 60 have already been read, of the 300 pages, 240 remain. Therefore, 4/15 times 240 is 64. Therefore, Monday and Tuesday, she read a total of 60 plus 64, which is 124 pages. Number 11, the answer is A. An integer chosen at random from this list. The probability that that integer to the power of 4 is greater than 100 is. Well, one thing you'll notice about this list is that it is pretty much the same numbers. The only difference is that some of them are positive and some of them are negative. So when you take any of these integers to the fourth power, the result will be the same. M to the fourth will be the same whether you have a negative 5 to the fourth or whether you have 5 to the fourth. Okay? So all we really need to do is just concentrate on one of these pairs, either the positive or negative, and the result will be the same for the other guy. So let's try 1 to the power of 4, that's 1. 3 to the power of 4, 9 times 9, I believe, which is 81. Okay, 5 to the power of 4, 25 times 25, 625. 7 to the power of 4. Obviously, these are going to be greater than 100. You don't really even need to do it, but just for the sake of doing it. And that's what? 6561? Yeah. So the ones that are greater than 100, which is what they want, are these guys right here. Negative 9, 9, negative 7, 7, negative 5, and 5. They will give results that are greater than 100. These ones will not. So of the 10 numbers, these 6 will give a result that is greater than 100. So the probability is 6 over 10. And of course, in lowest terms, that's 3 over 5. So number 12, the answer is E. 512x to the power of x is 64 to the power of 240. What is x? 512 to the power of x is 64 to the power of 240. Well, convert everything to powers of 2. So 512 is 2 to the power of 9. That is to the power of x. 64 is 2 to the power of 6. That is to the power of 240. This becomes 2 to the power of 9x. This becomes 2 to the power of 6 times 240, which is 1440. Okay. Now we have the bases are the same. That means those exponents are the same. So that means that 9x is equal to 1440. And divide through by 9. 1440 divided by 9 is 160. So number 13, the answer is D. In a school fundraising campaign, 25% of the money donated came from parents. The rest of the money was donated by teachers and students. The ratio of the amount of money donated by teachers to the amount of donated by students was 2 to 3. The ratio of amount of money donated by parents to the amount of money donated by students was. All right, let's say the total amount donated was $100. Let's make it easy. That means the parents, they donated 25% to that, so that's $25. And then you have teachers and students. And they're saying that the ratio for teachers to students in terms of the money they raised was 2 to 3. So this will be 2x and this will be 3x. Well, the $100 is divided among 3 parties. $25 went here, so that means here is $75. The amount raised by the teachers and the students. But 2x and 3x is $75. So 2x plus 3x is 75. So that means 5x is 75. So x is equal to 15. So that means this 2x is 30, and this 3x is 45. Correct? So now we have to figure out the ratio of the amount of money donated by parents versus students. So P is $25, students is 45, and divide through by 5 and get 5 over 9. So 5 to 9 is the ratio. Number 14, the answer is C. The cookies in a cookie jar contain a total of 100 raisins. All but one of the cookies are the same size and contain the same number of raisins. One cookie is larger and contains one more raisin than each of the others. The number of cookies in the jar is between 5 and 10 inclusive. How many raisins are in the larger cookie? All right. We have a total of 100 raisins, and the number of cookies is anywhere between 10 and 5. That's how many there are. And then they've got this large cookie, and then they've got some smaller cookies. And the large cookie has one more raisin than each of the others. So if each of these small cookies, let's say, has X raisins in it, the large cookie will have one more. So X plus 1 raisins. Now we've got to figure out a formula that includes that total. Well, the total is 100. How do we get that total? Well, it would be this number. There's n cookies in total. So if there's n cookies in total, this is n minus 1 cookies, and this is 1 cookie, obviously, because there's n in total. So the n minus 1, that number multiplied by x gives you an idea of how many raisins are here among the small cookies. And then you just have to say 1 times x plus 1 to get the number of raisins in that large cookie. So that is my formula, basically. And now I have to try to figure out what is n, and then I have to figure out what is x. But I only have one formula, so there's going to be some inspection involved here, because you normally need two equations if you have two variables. Okay, no problem. Let's do this. Nx minus x plus x plus 1. Oh, okay. That's interesting. The x is canceled, so I just get nx plus 1, but I can bring the 1 over, so that becomes 99. Nx is 99. Well, 99 is 9 times 11, and that is n times x. N is between 5 and 10, so n cannot be 11, so n must be the 9, and therefore the x must be an 11. See what I did there? It's basically based on inspection. So n is 9, and that is fine because it's within that parameter, and therefore x is 11. And remember, x represented the number of raisins on each of those small cookies. Now they want that how many raisins are on the larger cookie. The number of raisins on the larger cookie is x plus 1, and therefore x plus 1 is 12. So number 15, the answer is E. Rectangle PQRS is divided into 60 identical squares as shown. The length of the diagonal of each of these squares is 2. The length of QS is closest to. All right. So first, let's just figure out one of those smaller. I'm blowing it up. It's a little bit easier to explain when you're blowing it up. And let's explain first the length of diagonal of this little guy. So there's the diagonal. And I'll call this x and this x, and they told me that diagonal is 2. So that means by Pythagoras, x squared plus x squared is 2 squared. Therefore, 2x squared is equal to 4. X squared is 2, and therefore x is root 2. Okay. Now, in the question, they want you to figure out the length of QS. Well, QS is this diagonal from Q all the way to S. Well, that's going to be Pythagoras again. QS squared is equal to QR squared plus SR squared. Well, what is QR? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those sides. Each side was x, remember? So it's really 12x squared. Okay? SR, well, SR is 1, 2, 3, 4, 5. And each of those is x. So it's 5x squared. So that's what, 144x squared plus 25x squared. That's 169x squared. X squared is right here. It's 2. So 169 times 2. And that is going to be 169 times 2 is what, 338? Yeah, 338. And therefore QS is the square root of 338. And you're allowed to use a calculator on the Canadian exam, so that would be approximately 18.38. And 16 therefore is A. In the diagram, P, Q, R, S, and T represent 5 consecutive integers not necessarily in order. The 2 integers in the leftmost circle add to the 63. The 2 integers in the rightmost circle add to 57. What is the value of R? All right, well, P, Q, R, S, and T are consecutive integers. So x, x plus 1, x plus 2, x plus 3, x plus 4. Now, not necessarily in that order. They even tell you that in the question. We don't know which one is P, which one is Q, and so on. But we do know that if you add them all up, the sum is going to be 5x plus 10. And 5x plus 10 is equivalent to the sum of P plus Q plus R plus S plus T. Now, they told me that the 2 integers in the leftmost part add up to 63. So P plus Q is 63. So that's 63. The 2 integers in the rightmost circle add up to 57. So those two add up to 57. So that's 57. And then the only guy that's left is R. Okay. Hopefully this will be helpful, but unfortunately I got that X in there. Okay, no problem. Let's work with this. So simplifying everything, I will get 5x is equal to 120 minus 10, 110. So R plus 110. Yeah. Let me isolate for R. If I do, I get 5x minus 110. And then factor out a 5, x minus 22. Okay. So again, I got to do inspection here. Okay. Well, one thing is for sure is that R is some multiple of 5 because it's 5 times something. So if you look at the answer choices, let's see if there's any multiples of 5. There should be. This is a multiple of 5, and that's a multiple of 5. So the answer's got to be one of those two. So these two are gone. But I still have 2, so unfortunately, I'm still not home free here. Okay, let's look at both of those. That means R is either 20 or R is either 30. Okay. Well, let's see first. If R is 20, that means 20 is equal to 5 times x minus 22. That means, what's that? 4 is equal to x minus 22, and therefore x is 26. Okay. If x is 26, then we have 26, 27, 28, 29, and 30 as my 5 numbers. But then how can R be 20? R has to be one of these 5. So that's not going to work. So that means R must be 30, but just to be on the safe side, let's actually do it and see what we get for 30. Okay, so R is 30 this time. We've eliminated this. We pretty much got the right answer, but let's just do it. Okay, so that means we got 6 here, x minus 22, and therefore x is 28. Okay, so that means we got 28, 29, 30, 31, and 32 as my integers, and one of them can definitely be 30. So that works. So number 17, in a very thorough way, the answer is E. If m, n, and p are positive integers with m plus 1 over n plus 1 over p is 17 over 3, the value of n is. First, let's simplify this expression, and let's see what we get. So get a common denominator here, p and p. And let's see, that gives me 1 over np plus 1 over p. All right. Invert and multiply, and that just becomes p over np plus 1. And that's 17 over 3. Okay. So far, so good. Now, of course, we have to, again, get a common denominator, np plus 1, np plus 1. And that gives me mnp plus m plus p over np plus 1. And that's 17 over 3. Okay. So normally, you need the number of equations as variables. So if you have 3 variables, you need 3 equations. We don't have 3 equations. We don't even have 2 equations. We have only 1. So obviously, there's going to be some inspection here. First, let's concentrate just on the denominator. 17 over 3 is in lowest terms because those are both prime, I believe. Correct me if I'm wrong. So that means that np plus 1 must be equal to 3. Okay. That means np is equal to 2. Both of them, well, all 3 of them are positive integers. So how can I make n times p equal to 2? Either n is 2 and p is 1, or n is 1 and p is 2. That's the only way. All right, so let's figure out what happens to the numerator for each of those scenarios. First, let's do it for this scenario where n is 2 and p is 1. So we have m n p plus m plus p, and that's equal to 17. So substitute n equals 2. So we have m times 2 times 1 plus m plus 1 is 17. So that's 2m plus m is equal to 16, and therefore 3m is 16. And therefore, m is equal to 16 over 3. Well, unfortunately, 16 over 3 is not an integer. So this scenario is no good. Okay, no problem. We got another one, another scenario. Same thing. mnp plus m plus p is 17. Now let's substitute n equals 1 and p equals 2. So that's going to be m times 1 times 2 plus m plus 2 is 17. So that's 2m plus m is equal to 15, and therefore 3m is 15, and therefore m is equal to 5. And there we go. We got integer solutions. M is 5, n is 1, p is 2. What do they want? The value of n. Well, n is 1. So number 18, the answer is C. There are 2 ways of choosing 6 different numbers from the list 1 through 9, so that the product of the 6 numbers is a perfect square. Suppose that these 2 perfect squares are m squared and n squared, where m and n are positive integers and m does not equal n. What is the value of m plus n? Let's break up each of those numbers into its prime factors. So instead of 4, I write 2 times 2. 5, instead of 6, I write 2 times 3. 7, 8 is 2 times 2 times 2, and then 9 is 3 times 3. So we have to choose 6 numbers, and then in the end, that's got to be a perfect square. Okay, so this is going to be a little bit of an experimentation here. The first thing that we have to understand is that whenever you put numbers together, they've got to match up. So it's got to be 2 squared, or 2 to the 4th, or 3 squared, or 3 to the 4th, or like that. You can't have 2 by itself, or 2 to the power of 3. The exponents must be even. That's the only way you can get a perfect square. So that's very, very important to understand. So there's no way you can do that with the 5 and the 7, because there's only one 5 and there's only one 7. So 5 times 5 would not be possible. 7 times 7 would not be possible. So these 2 are duds. They're not going to help us. So we can only concentrate on 1, 2, 3, 4, 5, 6, 7. So we have to choose 6 from those 7. All right, let's experiment and see what we get. So I'm going to start off with this guy, 3 times 3. Okay, that's pretty good. Let's see here. I'll put in this 2 times 2. So far, I'm choosing perfect squares. Might as well put in this guy, 2 times 3. but then I've got to match them, remember? So I'll put a 2, and I'll put a 3, and then I'll stick in that 1. This gives me 3 to the power of 1, 2, 3, 4. And it gives me 2 to the power of 1, 2, 3, 4. Okay? When you do the math, that is actually equal to 36 squared. And therefore, that will be my m squared, where m is 36. All right, so I got one such value. Now we do the exact same thing again, and hopefully we will get another value. Let's use a different color. All right, so I basically, it's kind of interesting that there's only 7 choices. 1, 2, 3, 4, 5, 6, 7, right? And in the first one here, I chose 6 of those 7. The only one I didn't choose was this guy. So obviously, in order to have a different number, I have to choose that one. So 2 times 2 times 2. Okay, so I took care of that one. Now, I guess, I've got to experiment, figure out. There's only one that I'm not going to choose, right? Because I have to choose 6 of the 7. Okay, Well, let's see. If I'm wrong, I can always retrace my steps. Choose this guy. 2 times 3. I'll choose this guy. I'll choose that 3 in there. So my 3's match up, and so I'll do my 2's. So that's great. And then how many got? 2 more, right? Well, the only way is to put 2 times 2 and then to put the 1. So this was the only one not chosen this time. Okay, so this is 1, 2, 3, 4, 5, 6. 2 to the power of 6. 1, 2, 3, 4. 3 to the power of 4. Great. This is, if you do the math, 72 squared. So therefore my n is 72. So there we go. I got an m, I got an n. Now I just have to add them. And when you do, you get 108. So number 19, the answer is A. Isosceles triangle PQR has PQ equal to PR and QR is equal to 300. Point S is on PQ and T is on PR, so that ST is perpendicular to PR. ST is 120. TR is 271. QS is 221. The area of quadrilateral STRQ is. There's several approaches to this question. I'm going to show you one that I hope will help you. First thing is just cut that quadrilateral like that. Draw a line from S to R. So immediately STRQ is broken up into 2 triangles, STR and SQR. Well, STR is easy to figure out the area since this is a right angle. It's just 1/2 base times height. So 1/2 base, which is 271, and times height. And that's it. SQR is going to take a little bit more work. So we'll just put a little bracket there for now. We'll come back and fill it in later. The first step, of course, to figuring out SQR's area is to find what is the value of SR. Well, SR can be easily figured out using Pythagoras. ST squared plus TR squared. So that's 120 squared plus 271 squared. And that's going to be some big long number. 1440 plus 73441. When you add it up, you get 87841. And therefore, SR is approximately 296.38. Okay. Now I have all 3 sides. SR is 296 approximately. Okay. Now to figure out the area, some of you know this formula, but those of you that don't, I encourage you to learn it. If you have a triangle and you know the value of all 3 sides, you can figure out its area. And that is known as Heron's formula, commonly used on math contests. The area of the triangle, if you know all 3 sides, is S times S minus A times S minus B times S minus C, all under the square root sign, where A, B, and C are the side lengths, and S is half of the perimeter, A plus B plus C divided by 2. All right. So let's use that formula. First, let's figure out S. S is basically 221 plus 300 plus this 296.38, all divided by 2. And when you do that, you get a value of 408.69. Okay? So therefore, the area is going to be 408.69 times 408.69 minus A, which is 221. Multiply that by 408.69 minus B, which is 271. Oh, sorry, which is 296.38 to be exact. And then multiply that by 408.69 minus 300. And of course, all of that is going to be under the square root sign. All right, so no tricks, just applying heron-ons. So this is going to be 408.69 times 108.69 times 187.69 times 112.31, all under the square root sign. And when you crunch out these numbers, you get A is equal to 30600. You should get an exact value if you had used multiple decimal places. All right, well, this was SQR, so plug it in, 30600. And therefore, when you do this, you will get a total of 46860. And therefore, number 20, the answer is C.